Hey, what's up? It's your old pal, Mr. Cook. We just got done working on 11 through 15. Now it's on to the 5th page of the review, and we're working on the Algebra 2 practice final, the multiple choice review. Going through the problems one by one or page by page, I guess. So we're going to do 16 through 19 now. Make sure to have your calculator out if you have a graphing calculator or, scientific calculator. Let's try and answer some of these ones with the scientific calculator. See how we can do it. All right, so find the zeros of this function. Whenever it says to find the zeros, it's all factored out like this. All you have to do is just take each of the individual factors with x in it and set them equal to 0. So if I take the first one, x plus 2, and set it equal to 0 and solve it, I get x is equal to, if I subtract 2 from both sides, negative 2. If I take the next one, x minus 2, and set it equal to 0, solve for x, add 2 to both sides, I get x equals 2. And then for the last one, 2x minus 6, if I set that equal to 0 and solve it, if I add 6 to both sides, I get 2x equals 6. Divide by 2, I get x equals 3. So those are my three solutions, 3, 2, and negative 2. So 3, 2, negative 2, C would be my only answer for that one. All right, so that's number 16. 17, find all the possible rational roots. So this is from the rational roots theorem. It's pretty easy also. All you got to do is take the last number and the first number, so 7 and 2. You put the last number on top, the first number on the bottom, and then list off their factors. So the factors of 7 are 1 and 7. The factors of 2 are 1 and 2. And then you just make fraction combinations of each of them. So it's like 1 over 1, 7 over 1, 1 over 2, and 7 over 2. And then just put, reduce them and then put plus or minus in front of them. So 1 over 1 is just 1, so plus or minus 1. 7 over 1 is 7, so plus or minus 7. 1 over 2 is 1/2, so plus or minus 1/2. 7 over 2 is 7/2, so plus or minus 7/2. And that one is C. So C would be my answer there. The speed of a car is modeled by the function, and then they give you an equation. Determine the average rate of change over the interval 0 to 4. Average rate of change, what that means, it's a fancy way of saying slope. So this is number 18. We're going to use slope on number 18. So the slope formula, m equals y2 minus y1 over x2 minus x1, finds us the average rate of change over like a linear equation. This one's nonlinear, so that's why they changed, instead of calling it slope, we call it average rate of change over that. But despite that, it's actually really easy to do this. The interval here gives you the x values for two coordinates. Oops. So like 0 is one of the x values, 4 is the other x value. You need to find the y values. So to find the y values, you use this equation. This gives you the y values. So let's plug in 0. 2 times 0 squared minus 3 times 0 plus 8. So let's use our little calculator there. 2 times 0 squared minus 3 times 0 plus 8. 8. Okay, so 8's our answer for that one. Let's plug in 4, doing the same thing. So 2 times 4 squared minus 3 times 4 plus 8, 28. All right, now we have our two coordinates, so now we use the slope formula to find the average rate of change. So we do y2, so 28, minus y1, 8, over x2, 4, minus x1, 0. 28 minus 8 is 20. 4 minus 0 is 4. And 20 over 4 is 5. So 5 is our average rate of change. There it is. Which is a graph of a function of odd degree with a negative lead coefficient. Well, this one is all about something called n behaviors. So there's no formula for n behavior. You just kind of know how the behaviors for the n behaviors look. And it's broken up best in a table. So I'm going to draw the table real quick, and then we'll evaluate the graphs. So n behavior is based off two things: degree, and then also the positive or negative sign or the lead coefficient on the polynomial. So the degree is either going to be an even number or an odd number. The sign, the lead coefficient, is either going to be positive or negative. If the degree is even and the sign or the lead coefficient is positive, On the left of the graph, it's going to be pointing up. Then some stuff will happen in the middle, and on the right, it'll be pointing up as well. If we have an even degree and a negative lead coefficient, it's going to be going the opposite direction. It's going to be pointing downwards on the left, stuff will happen in the middle, and then it'll point down on the right. With an odd degree and a positive lead coefficient, it'll be pointing down on the left, then the stuff will happen in the middle, and then it'll point up on the right. And if you have an odd degree and a negative lead coefficient, it'll start by pointing up on the left, then some stuff will happen, and then it'll point down on the right. So let me go through each of these and then we'll answer the question. So this one points down on the left, up on the right. So down on the left, up on the right means that this A is going to be odd degree and a positive lead coefficient. This graph, it's pointing up on the left, pointing up on the right. So up on the left, up on the right means that it's going to be an even degree and a positive lead coefficient. This one's pointing up on the left, down on the right. So it's going to be an odd degree, and it's going to be a negative lead coefficient. And then the last one, D, is pointing down on the left and down on the right. So it's going to be an even degree and a negative lead coefficient. So this one says that we're looking for the function with an odd degree, so one of these two, and a negative lead coefficient, so this one. So C would be our answer. And this is all dependent on you just knowing the end behavior. I'm pretty sure that I made a video on end behavior also. So if any of this stuff is confusing to you, just look for the key words or, the sections that these are attached to, and just look those up, in the old videos that I have. Well, that's it for this page. We're going to move on to the next page for the next video.